My name is Jean-François Flo. I'm a professor of biology and genomics at the University of Brussels in Belgium. And I've been working together with Shaban on sulfidic cave for 14 years, since 2010. At that time I was working in Germany. And we started this long-term collaboration about these fascinating ecosystems. Actually, I work on two different types of ecosystems. I work on tropical coral reefs, with this oasis of life in the middle of the sea, teeming with fish and corals. And I work on sulfidic caves, which are kind of the equivalent of coral reefs, but underground. Normally, normal cave, you don't have much life. You may see one little shrimp from time to time, but in these sulfidic caves, you have like oasis of life. It's teeming with life, lots of insects, a lot of arthropods, I mean crustaceans, lots of bacteria living there. So sulfidic caves are like the coral reefs underground. And I'm studying in particular how this biodiversity came to be and how these two very different types of environments have shaped the evolution of these organisms that live there, both on the morphological aspect, or they look like from the outside, but also in the genome. So I sequence the complete genome and look at the genes inside and try to understand how things happen to get the way they are. Like cave organisms, they become all white and they lose their eyes and their appendages elongate. So it's very fascinating type of adaptation. That's what we try to elucidate using genome sequencing. Yeah, so Sulfur Cave is a very interesting place, even from a geopolitical point of view, because it's right at the border between Albania and Greece. So sometimes we go inside from Albania, then you need to walk against the current. It's a bit difficult sometimes. Or sometimes we go from the Greek side, which is a bit easier. But then the danger, if you go there from the Greek side, is if you fall in the water and you're carried by the current, you end up in Albania with no passport, nothing. So yeah, better avoid it. And just crossing the river to go to the cave, I think we crossed the border between Albania and Greece 5 times. Luckily, yeah, because each side of the river is a different country at that place, and we need to go in the shallow water. So we cross the river 5 times until we arrive into the cave. So we cross the border 5 times. Luckily, we don't need to show a passport and get stamped every time. We would lose a lot of time. And then once we are inside the cave, within the cave itself, we cross the border again. So in Greece, the closest city is Konitsa. So usually when we go there from the Greek side, we stay in Konitsa. And usually when we go there from the Albanian side, we stay in Permet. Or sometimes we do actually camping just next to the cave entrance. There's a small road there and we can be like 10 minutes by walk from the cave entrance, which is very nice. For this type of exploration, it's really a question of convenience. It's a bit faster to go from the Albanian side, but you have, of course, a lot more like controls at the border because this is not the Schengen area. So it has good and bad sides. It's about the same. And I think what I like a lot is if you drive from the Greek side, then you arrive into Albania. It's nice because Greece is already very beautiful, but then you pass the frontier and you see Albania, which is even more wild. So it's a good way, I would say, to go from the Greek side into the Albanian side. So you get an increase in beauty as you pass the frontier. If you come from the Albanian side and you arrive into the Greek side, which is more developed, with more houses, then you're a bit more like, okay, it was more beautiful before. So among the sulfidic caves I've been working in the world, the ones here are the most spectacular. Like I've been working in about every sulfidic cave in Europe together with Shaban. So we started by working in Italy, in Frassassi, near Ancona. There's a very beautiful cave, very famous there. We worked in Movile Cave near the Black Sea, in the Mangalia region of Romania. We discovered some new caves and we worked there in Melisotripa, it's near Larissa in Greece. They're all very interesting, very beautiful. But the caves here are like one level higher in terms of biodiversity, of incredible networks. Every time we go there, I think in the last year I've been 4 or 5 times into Sulfur Cave. Every time we go there, we discover new things that we didn't see the time before because there's just so many things to look around. So yeah, we never reach the moment where we're like, okay, we know the cave, we don't need to come back anymore. Every time we go back there, we discover a new type of bacteria, new animals. It's really incredible. And all this biodiversity has very important impact for mankind because they contain genes that may be useful for humans actually. So in Belgium, in the country where I work, for instance, people work in caves isolating bacteria that grow on the wall of the cave and they find new antibiotics like this. But this is just little variations on known antibiotics, but it's still very useful because there is no resistance yet against it. So caves are a very good source of antibiotics for fighting the human disease. But here these caves are completely different. So one of the things that I hope to do is by sequencing the genome of the bacteria that are there, maybe we're going to find new genes that can be used to develop new antibiotics and save humans actually. So the key to human health may be actually hiding in these caves. I would say so. I mean, of course, that's why I think it's very important that we weave collaborations with local scientists. That's why in particular microbiologists from the University of Tirana tomorrow when we meet with them. The idea is, of course, if we find new molecules of interest in bacteria that grow here, that should benefit Albanian researchers, Albanian economy and everything. To make absolutely no sense to just get them and bring them to US or to Belgium. No, they are part of the richness, the unknown richness of Albania. Everybody knows the beautiful richness of the landscape and the nature, but on the ground there's also a lot of potential richness that needs to be protected, discovered, and that could bring a lot of economic wealth actually to the country. I mean, sulfidic caves are always a bit dangerous. So they smell very strong like rotten egg. I like the smell actually. I'm one of the crazy few people who love the smell of rotten eggs. Other people don't like it. But what this smell means, it's actually it's a toxic gas. So in some caves, not here, but in other caves where I work, like in Romania, we do actually bring mask gas, or we bring even tanks of oxygen, like for scuba diving, so that we have our own air to breathe, because otherwise we would die. But here we don't really need that. We just need to be a bit cautious. Like the key is, usually people say, as long as you can smell the smell, it's fine. If you don't smell the smell anymore, then it means possibly that your nerve cells in the nose have been killed already by the gas, because it means the concentration is becoming toxic. And then if you don't smell it anymore, you should really exit fast, because the next step you could die actually. So it's a type of a little bit scary situation, something like, I don't smell the smell anymore. What happens? Is my nose already dead? But this is, it's part of the job. And I mean, I have to say, for me, field work in biology is the most exciting part. I've been working in many dangerous places, in hot springs and geysers where you can just get boiling water at your face from a little volcano, or in caves full of toxic gas, or even coral reefs sometimes are in dangerous and remote area. But they are so interesting place to study that it is definitively worth the danger, I would say. And then in terms of the most beautiful discoveries I had here in caves in Albania, I mean, the subterranean landscape is incredible. Usually, I'm used to going to caves in many places, so I know a bit what to expect. Sorry. But here, it just blew my mind every time. Like Sulfur Cave with this entire wall of spiders, it's just a unique place in the world. It's completely crazy. The spiders that are living in this cave, in Sulfur Cave, are the same spiders, the same species apparently, that I have in my backyard, in my attic actually, in Belgium. It's Tegenaria domestica. It's a very common species. But in Belgium, you never see two of them together. They stay apart, they avoid each other. Here, it's like a giant spider colony where they live just millimeters from each other, and they seem very social. It's just completely crazy. So I could stay for hours or even days just watching the interaction between these spiders, and there are other species living with them, so they interact not only among themselves but with other species. It's just so beautiful. And and even the geological landscape. There's one cave that we didn't mention yet, which is Turtle Cave, which is near Sulfur Cave. And it has a bit about the same biology as Sulfur Cave, but the entrance is a bit more difficult because you need to go down a rope. It's a bit more tricky and dangerous to get inside. But once you arrive inside, you're on top of a little mountain of gypsum, of white rock, and it's like a huge pile of sand. So you walk down, it just feels like being on the moon actually. And at the bottom of this, you have this round circular lake with a very blue color. And then on top of it, you have circular marks on the ceiling of the cave because of the geochemical reaction with hydrogen sulfide. It's just mind-blowing, just so beautiful. I wish I were an artist who could do like paintings. We just go there, sit, and just paint. So inside this cave, it's a very specific type of food web. Normally, almost all ecosystems we talk about are based on solar energy, photosynthesis. And even like if you study about ecology at school, they always give the example of an ecosystem with the sunlight starting everything, and then you have bacteria or organisms. There in the cave, it's chemical energy. And so what happens is the water is rich in hydrogen sulfide, which here has a reducing power. It's a negative redox potential in technical term. And then above it, you have the air, which is oxidizing. It has a positive redox potential because of the oxygen. And at the interface between the water and the air, so on the surface of the water, you have bacteria that are specialized in utilizing this gradient of chemical energy. So what they do is they combine hydrogen sulfide with oxygen, or sometimes methane with oxygen, and they burn this component and make their living out of it. And the effect of that is, so you have this bacteria growing very happily at the interface between the two layers, and then you have animals who eat these bacteria. So the animals, they can be of several types, but here in Albania, which is very special, it's usually little larvae of insects. In other caves I work on, it's more like crustaceans who are eating the bacteria. Here it's insects, little aquatic insects. The larvae are eating the biofilm, and then they get into adults, the adults fly, and then they get eaten by the rest of the food web. So the spiders, the the scorpions, the pseudoscorpions, all these insects are eating actually this first layer of the food web, the animals who eat this biofilm. So I'm not a mineralogist, but what is very striking in the caves is sulfur. You can see yellow on the walls, so deposition of sulfur. There's one place in Sulfur Cave that we call Sulfur Chapel, because it looks like a church all covered in yellow. It looks like this Orthodox church with gold on the wall, except it's not gold, it's sulfur. But it's very, very beautiful. And you have usually in these caves, you don't have many minerals deposition. It's more like the hydrogen sulfide is corroding everything. So you see rocks full of holes because hydrogen sulfide is corroding, making holes through the rocks. So there are not many minerals of interest to humans. The interest is more like biological interest. So, what we need to do is to prevent people from going into the cave getting sulfur. In the Middle Age, for instance, many of these sulfidic caves were used by people to collect sulfur because it was very rare, very difficult to get sulfur. And even nowadays, in some places, people go and they scratch the walls to get sulfur for burning at home because they like the smell or something like this. But yeah, it's very important to explain to people that this sulfur is actually, it's a treasure in itself. It's a slow deposition of sulfur by bacteria during thousands of years. So if they just scrap it just for them, just for fun, just for them to bring back a bit of sulfur at home, it actually destroys the environment. And so it's a bit of educating people. Also because people who don't know, they see something yellow on the wall, they think, whoa, it's gold. And then they get excited. And no, it's not gold, it's just plain sulfur. So we are starting to publish papers about this cave to raise awareness. And we try to make these papers available to everyone online. You know, some scientific journals, you need to be in a university to have access to it. So we try to publish this paper in journals that are accessible to everyone, so that everybody interested can look into them. And I really hope that one of these days I'm going to get some email from some local students from Albania who are like, oh, I want to know more about this cave and what can I do? And I would be very happy to welcome them in my lab in Brussels, for instance, where we have students from all around the world, and then they can learn all the techniques, like to analyze the genome of the bacteria and to understand the biodiversity, the food webs, and then apply them in their home country. That would be absolutely wonderful.